Hi everyone, this is Miss Emily and I'm here at the Central Library by myself to do hands-on science for you today. So, first of all, let's talk about what you need for today. First of all, you need balloons. Probably not that many, at least one, because we are going to be blowing up these balloons without using any air from our mouths or our lungs, without using our hands at all. Well, you might need to put your hand on there to keep things under control. We'll see. But we're going to inflate these balloons, fill them with air without blowing into them. So you're going to need some balloons. So in order to blow these up, we're actually going to do a chemical reaction, which I think is what a lot of people think of when they think of science. And we're going to use two things that you probably have in your house. In fact, you may have mixed these two things before because they are things that you have in your house and in small quantities are pretty safe. But they can cause a pretty cool reaction, and so you can use them to make a volcano. If you've ever done elephant's toothpaste, you might already have mixed these two things together. So without further ado, let me introduce our two star ingredients today, which are baking soda and vinegar. So this is white vinegar, so it's clear. I actually brought some apple cider vinegar too, because that's yellow, just to show you it's not just water. It is vinegar. Other things you might need, you're going to need some kind of container like this. A little bigger than this is okay. You don't want too wide of a mouth because you're going to stretch the balloon over the top. And you might want something you can use to measure. So these are tablespoons, often used for baking. These would be great for the amounts that we're measuring. And also, this is called a funnel, and I'm going to be using at least one of these. You might want one that you use with your vinegar and one you use with your baking soda so they don't get mixed while you're filling things. So this is your funnel, and it's helpful for putting liquid or powdered ingredients into a smallish container. So those are the materials that I have with me today. I also have pen and paper and a ruler. I didn't grab a timer, I'm just gonna count, but when you are conducting your own science experiments, it's really helpful to measure as accurately as you can and write down your data. And that's when you can really draw some interesting conclusions. So I will be writing things down, making notes for all of us. And if you do this on your own, I encourage you to have pen and paper handy and maybe some things you can use to measure the results of your experiment. So without further ado, let me show you this chemical reaction. Oh my goodness, my phone is sliding around, and then I'll tell you what causes it. So I'm going to take one of my little containers and I am going to put 3 tablespoons of vinegar in it. So, as a scientist, you may want to use all 5 of your senses to check out these ingredients we're using today. So, if you smell your bottle of vinegar, it has kind of a sharp smell. I don't know how to describe it, but it'll be familiar to you, I think, if you smell it. It's not exactly nice, it's not disgusting, but it's like, ooh, it'll wake you up a little. So it has kind of a sharp smell. And if you taste it, it's very sour, which it is okay to taste a teeny bit of vinegar, but you might not like the taste. And if you feel it, it's wet like a liquid. So that's some information about vinegar, but I need to just grab my other funnel so that I can accurately measure. We're going to do 3 tablespoons of vinegar. So yeah, this is my vinegar tablespoon. So you can count with me. 1, 2, 3. All right, so 3 tablespoons of vinegar in there. I'm gonna put my vinegar and my vinegar measuring spoon and my vinegar funnel over on this side. So now I'm gonna measure my baking soda. The baking soda is gonna go right into the balloon. So this is the one where you really need a funnel. or you can have someone else help you. They could hold the balloon open and you could spoon the baking soda in, but it can be a little tricky to get your baking soda into your balloon unless you have either some help or a funnel. So I am going to measure 2 tablespoons of baking soda, because I tried 3 earlier and the third one just kind of clumped up in the balloon and wasn't even part of the reaction. So I think I just overdid it a little. And I have to kind of, you can see how it gets full. I just spilled a little. That is not the most scientific. I have to kind of tap it to get it to go down into the balloon. And maybe you can kind of see the baking soda is filling. I think, you know what, honestly, 1 tablespoon might be enough, but I'm going to go ahead and do the second one. We'll see how big our reaction is. All right, so just tapping it so that the baking soda goes all the way down into the balloon. Come on, come on, come on. Almost there. Okay, great. So again, I'm going to put my baking soda and my tablespoon and my funnel I used with the baking soda over here, so everything's separate. So as a reminder, this is my container with the vinegar. Here's my balloon with the baking soda. Now you have to stretch the top of the balloon over this container, and now I'm going to just kind of lift up the balloon so that the baking soda falls in with the vinegar. And as you can see, the balloon has inflated, and it looks like it's about 9 inches from the bottom of my container to the top of the balloon. And I forgot to count to see how quickly it inflated, so we'll focus on our height measurement. And gradually the air is going to come back out of this, but as you can see, it's staying inflated for a little while. So I'm going to make some notes about what we did this time. So we did 3 tablespoons of vinegar and 2 tablespoons of baking soda, and our resulting inflated balloon, the top of the balloon was 9 inches from the table. So our balloon inflated 9 inches high, but 9 inches includes the height of the container. All right, so those are our first results. So let's talk about what happened. That was amazing, right? Whoa! You could hear the reaction happening in the balloon. It inflated. I didn't put any air in it. Where did the air come from? Here's what happened. So vinegar is an acid. In fact, this is reversed because my camera is mirror imaging, but if you can read backwards, it says 5% acidity here on my vinegar. So vinegar is an acid and baking soda is a base. And when you mix an acid and a base, they have a reaction. So you know everything is made up of teeny tiny particles called atoms, and they actually trade some teeny tiny particles. When they react together, the baking soda receives a proton from the vinegar, and it changes. The baking soda transforms into 2 things: water and carbon dioxide. Carbon dioxide is a gas, and you can kind of see how what's left here is a liquid, clearly, right? So the baking soda transforms into water and carbon dioxide. Carbon dioxide is a gas, and it's light, so it rises up and it fills our balloon. So that's what's happening. Let's see if we change some variables, if it changes our results. So our balloon is still pretty inflated over here, which is pretty good. So we're going to do some other experiments. So what are some things that we could change is the question, right? We could change the size of the container we were using. We could change the amount of baking soda or the amount of vinegar. We could change if we could add another ingredient to see what the results are then, which is something we're going to do at the end. Can you think of any other things that we could change to see what the effect is? This is your opportunity. You can try this at home as well. Perhaps the size of the balloon, I don't know. But for the next one, I think what we'll do is we're gonna try changing the amounts that we put in, and also we will try using a different kind of vinegar, right? Because I used white vinegar the first time, saw that it's nice and clear, and so I brought some apple cider vinegar so we can try apple cider vinegar. So we'll try a different kind of vinegar and we'll try different amounts. So let's start by trying the different amounts. So that first time we did 3 tablespoons of vinegar and 2 tablespoons of baking soda. But like I said, I almost feel like all the baking soda isn't getting used up. So I'm going to try a smaller amount. Let's go stick with 3 tablespoons of vinegar and 1 tablespoon of baking soda. And remember, the first time our balloon inflated till the top of it was 9 inches above the table. So let's see if we get a different result, the same, and that'll be our first experiment. So the variable that we're changing is the amount of baking soda. So we have to go through the same basic process again. So I need my funnel for vinegar, and I need my vinegar, and I need my tablespoon. So again, we're sticking with 3 tablespoons of vinegar, which is our acid. 1, 2, 3. Okay, and this time we're going to use just 1 tablespoon of baking soda. So here's my balloon, here's my funnel, and I'm going to grab a scoop of my baking soda. This time just 1 tablespoon. Let's get this out of the way so we're not distracted. Tap, tap, tap to get it to fall down into the balloon. So I don't know if you can see that there's stuff in the balloon. Almost all gone. Okay, looks good. So, put my vinegar stuff over here, my baking soda stuff over here. I'm going to take the top of the balloon and put it over the top of my container and lift it up so the baking soda falls in. Whoa! This is interesting and I don't know why it's doing this. It's a totally different shape, you guys, and it's definitely taller and thinner. I feel like this is an issue with the balloon. Also, I don't have like a perfect seal here. I'm going to show you. I don't know if you can hear that, but can you see there's actually a puddle outside of my container. So I changed more variables, I think, than I meant to this time. Let's see. This time it is 11 inches tall. And that's really interesting. Okay, so what I think is going on here, although I do not know for sure, is some of my baking soda is not even falling down in. Can you see how there's some here next to my thumb? Some of my baking soda is still not even falling down into the acid. So although I put a smaller amount this time, I think more of it initially fell down inside and reacted, but I don't know, I thought maybe some of it got hung up here, but now it doesn't seem that that's the case. This is very interesting. Let's do another one with the same ingredients and the same amounts we used this time and see if the shape of the balloon is the same. So we're going to do this again. We're going to do 3 tablespoons of vinegar, 1 tablespoon of baking soda, and we'll compare our final one to this. Because I also had the spillage this time too. But I feel like I actually had a better reaction even though I had less baking soda. But my theory is, my hypothesis, is that more of the baking soda actually got into the acid. When I was using a larger amount, I feel like it was just getting hung up in the balloon. I don't know if you can hear that. It's still buzzing. All right, so we've got more. Let's keep going. So let's do our acid first. We're sticking with our 3 tablespoons and we're sticking with the white vinegar. We're not going to try the apple cider vinegar because we have enough variables going on. So 1, 2, 3. All right. And now we're going to add baking soda directly to the balloon. Let's try a green one. Just 1 tablespoon of baking soda was more than enough last time for a pretty dramatic reaction. So let's see what happens this time. All right. All right. So baking soda into our balloon. All of it's in. Okay, great. All right, here we go. My ruler ready this time. My tray is becoming a mess here, but that's okay. So we're gonna put the top of the balloon. I'm gonna try to really pull it all the way down this time so it doesn't come off. And there we go. All right. Can you see how the whole container is full of bubbles? But this time, my balloon did not shoot up nearly as high as last time, which is very interesting. This time I got, looks like 9.5 inches high. So, very interesting. So just to review, these other ones are losing their air. This one's still buzzing, you guys. I don't know if the fact that we let some air in or the fact that there's still some baking soda here and so it's still trickling in because that one is still kind of reacting. So there's our first one, our second one, and our third one. So we're definitely getting some interesting different results. So as scientists, let's keep going. I want to do one more where we do 3 tablespoons of vinegar and 1 tablespoon of baking soda. So we're going to have 3 that are the same because we did that twice and we got 2 kind of different results. So let's try it one more time and see what we get the third time around. All right, and then we'll try something different. And you can do this on your own. It's probably more fun than watching me, so I encourage you to do your own experiments. But here's our container. Remember, we're doing 3 tablespoons of vinegar. We're sticking with our white vinegar for now. 1, 2, 3. And now into the balloon. Let's see, we haven't done purple yet. Let's do a purple one. It's very convenient to have different colored balloons. I don't have to so much keep track of, label my different experiments because the color helps me tell them apart. Take a scoop of baking soda and put it into our balloon. Tap, tap, tap to get it to go down all the way. All right, I'm really gonna try to perfect my technique this time and get all of the baking soda into the container. So, gonna put it on nice and tight and try to flip it over all at once. So there we go, put it on nice and tight. Here's my balloon. Let's see how quickly I can get all the baking soda into the acid. Okay. So this time, I'm having a very strong reaction. Some of it is shooting out. It's making a mess over here. That's why we're using a tray. This one is going so high, you guys. Oh my gosh. It's a foot high, 12 inches. Much higher than the others. And the shape, similar to this one, which is very interesting. So I'll be honest, I feel like I would have to do this a few more times to figure out why sometimes I get this shape and sometimes I get this shape. So if you do your own experiments and have your own results, please let me know if you can figure out which variable is causing these different shapes. It does make sense that when it goes to this shape, it goes higher because we're talking about the same amount of carbon dioxide probably, and if it's filling out this way, it's not going to go as high since these are shooting higher and not this way. That part makes sense to me, but I don't know what's causing some of them. And both of these are also ones where it came off the edge a little and some of it shot out. And I don't know if that escaping is a factor. I think you can tell that there's air escaping from these because more of the air is still in these two where we didn't have a leak. The balloon is still pretty full, whereas these two you can see the air is leaving. All right, well, the last thing we're gonna do is just try adding another variable. I haven't tried this one yet, so it might make a huge mess, I don't know. But we are going to try adding a teeny bit of dish soap to our vinegar because I read that this could make the chemical reaction even more dramatic, so let's try it. I've got one more bottle, and we're gonna do the same thing again. We're gonna do 3 tablespoons of vinegar. So 1, 2, 3, But this time we're gonna add a little bit of dish soap. Now, if this reaction is more dramatic, can you think of a reason why dish soap would make the reaction more impressive? What do you know about dish soap? What does it do? What do you usually use it for? All right, so I'm just spinning to kind of mix it together. If I had a tool to mix it up, that would probably be a little better, but I only have so many tools here with me today in the library. And now, let's see, for our last balloon, let's do a blue. And I feel like I got my baking soda funnel slightly contaminated because there's a lot of acid on my tray now. So let's take a scoop of baking soda and get it into our balloon. All right, so our final experiment for today. We've got 3 tablespoons of vinegar. We have a little bit of dish soap mixed in with our vinegar, and we've got our 1 tablespoon of baking soda. So I'm gonna put the top over this. Oops, that was almost a disaster. Put the top over this nice and tight, and then try again to get all the baking soda into the acid, like kind of at the same time as quickly as I can. You ready? Here we go. And once again, we have this bizarre shape. Okay, so can you tell what happened because we added soap? Oh, we have an explosion coming. I don't know how clearly you can see this. I might have to take the balloon off so you can truly experience what's going on here. This balloon is filling with bubbles, and they're starting to escape over the sides. So this is the result of adding some dish soap. It doesn't change the height of the balloon. This one is only about 11 inches, so not as high as all of ours, but we have this foam going on. This is definitely, looks like we're doing some serious chemistry here. Very dramatic. If you didn't have a balloon on top, you would have bubbles everywhere. And as it is, my balloon is full of bubbles, which I don't know how clearly you can see, but I think you can see it a little. And if this, and the bubbles just keep flowing out and covering my whole pan. So I have, I'm getting ahead on cleaning because I have soap bubbles now just streaming out. I feel like our experiment is over, but I want to keep talking as long as the bubbles are coming out. So let me just remind you that what is happening here, I also feel like at any moment the balloon may just pop off and go flying, but probably not because it has all of this extra space up top that it could fill. And now that we're leaking out the sides, I think all the pressure could go that way. Well, so what we're doing is we're mixing an acid and a base. And when that happens, the baking soda, which is the base, it receives a proton from the vinegar, which is the acid, and it transforms. It turns into water and CO2, or carbon dioxide, which is a gas. And so the chemical reaction we're doing in the bottle produces a gas. If we didn't have a balloon on top, you wouldn't be able to see that as clearly, but the balloon fills with the gas that we've created by doing this chemical reaction. So thank you so much for joining me for Hands-On Science today. Our experiment is continuing, but it's pretty much the same thing you've already seen. I'll give you a glimpse of my very messy tray before I sign out. But thank you so much for joining me today. I hope you had a good time. Ooh, I now have baking soda all over my camera. So I have a lot of cleaning up to do. This is our last Hands-On Science for a little while, but we will have a lot of other fun Facebook Live programs coming this summer, so I hope to see you then. Thanks so much for joining me today. And bye for now. Okay, also, you can't hit things on your phone when your hands are dirty. It doesn't work very well, so let's try again.